Yo, 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 yo. This is Brendan, and this is the 2010 question 6 FRQ. I think that this is a really good example for giving us what we would need to know for the AP exam in May. Some of these examples are really helpful. So the first thing that I like to do is, instead of just skipping to A, is I like to actually identify what I'm going to use for every single problem, just so I know that I know what I need to know for each problem. So for the first one, I know that I'll need to write out a few terms for cosine of x about x equals 0, and I'll need to use this series, to write out the next few terms for cosine of x minus 1 for x squared. And then I'll use, and the general term for f about x equals 0, I know it's centered around 0, so I don't have to write anything. And then, use the Taylor series for f about x equals 0. Found in part A, determine whether, so that means it is a AB question determining concavity. So all we have to do is just find f double prime of 0 and find out if it's positive or negative. And therefore, if it's positive, it'll be concave down, so it'll have a relative min. If it's negative, it'll be concave. No, if it's negative, it'll be concave down, so it'll have relative max. Concave up, it'll have a min. The fifth degree Taylor polynomial for g about x is equal to 0 is just writing about a few terms of this new equation. So we'll use our original terms and put them onto there. And then we would use these terms to evaluate the Taylor polynomial. And I'll know that we'll use the fifth degree, but it'll only ask us to use the third degree. And we'll see why we need to use the fifth degree later in the alternating series error. Okay, so let's go over to A. Little piece of advice is that I would say these four terms are definitely the most important to know for the AP test. You should remember their general term, maybe even remember a few terms to write out so you don't forget them or don't mistakenly use them, because cosine of x and sine of x are definitely the most commonly used. Okay, so for cosine of x, I just wrote this based off of memory. Just wrote off a few terms, 1 minus x squared over 2 factorial plus x to the power 4 or 4 factorial. And then I would just use this by plugging it directly into the general term, because I didn't memorize the terms myself. Okay, so we have to remember that f of x is cosine of x minus 1 over x squared. And now when it's not equal to 0 and x equals 0 and a negative 1. Okay, negative 1 half. So negative 1 half will be our first term because we subtract these terms by 1. So we'll have like a new kind of like starting term. And then for each other term after that, we divide it by x squared. So for each term. And then we add this by 2 and this by 1 because we have a new first term. So it kind of shifted everything a little bit. So we have to make sure that's added in. Okay, and then it starts at n equals 0, obviously. So this is part 1. It's pretty simple. Just definitely very important to know these four and apply those. Okay, so use the Taylor series for f about x equals 0 found in part A to determine whether f has a relative min, relative minimum, or a neither at x equals 0. So this is asking us to identify what f double prime of 0 is in an equation. And if we remember that f of 0 over 0 factorial plus f prime of 0 over 1 factorial times x minus c I'm just writing out what the Taylor series would look like without any numbers at all, just writing x in the center. So f double prime of 0 over 2 factorial, and all of that multiplied by x minus c to the power of 2. So we're looking for x to the power of 2. And what would you know? We would write out our terms again for f of x, and then we would see that we have x over 2, or like x to the power of 2. And the coefficient for that is 1 over 4 factorial. And here, that's not the right general term, it's right there. But we would see that, first of all, we have to identify that f prime of 0 is equal to 0. There's no x term. So that means it goes from positive to negative, or it's just plain out 0. We have to know that. So, but the main part here is that f, we have to like define this just to give a reason for our answer or justification. And for f double prime of 0 is equal to 1 over 4 factorial, f double prime of 0 is equal to 1 factorial. And because that this is 0, it looks like this graph, so it's always going to be concave up, so it'll be relative min. So we stated, that's why we stated this. Therefore, by the second derivative test, f of x has a relative min at x equals 0 because it's positive and it's concave up. Okay, so write the fifth degree Taylor polynomial for g about x equals 0. So g sub x is equal to 1 plus the definite integral from x to 0 of f of t dt. So I think probably the best thing to do to help me so I don't mess up is, because I did mess up on this one, is to always write these terms again. Don't always keep looking up at them, trying to take a shortcut. This shortcut would most likely result in something like just like an error, like numerically, like 1 plus 1 equals 3 or something like that. So just rewrite, make sure it's correct. Like, oh, see, like I have a mistake right here. Like, wait, no, that's correct. Never mind. But yes, it should be that. Okay, so in order to define this, we have to, okay, so the first thing I would do, I would write out g sub x is equal to 1 plus, and then I would look at these terms. Okay, so this is what I did. So I added 1 in the beginning so I don't forget it, and then I wrote out what I actually did the first time is I wrote these terms again. Okay, so but because it's definite integral and you just multiply everything by x. So it's 1 minus x over 2 factorial plus x to the power of 3 over 3 plus times 4 factorial minus x to the power of 5 over 5 times 6 factorial. So the way I got this is I just anti-derived negative 1 over 2. So I'll just know that after that it would be x. So x over 2. And also something that I really like to do is I like to just like in my mind derive each one individually and make sure I'd get the same answer as this one so I don't mess up. So x to the power of 3 over 3 times 4 factorial, divide that, it would be x to the power of 2, and then you would subtract 3 out, and then you would get that again. So once again, here are your terms. Third degree polynomial is what we will use in the next one, but here is our fifth degree polynomial. Oh, and here's an important tip. Obviously, we don't need to write c because it's definite integral, so we don't have to worry about that. Okay, so for D, this is our alternating series error. We can identify this because it's almost giving us the formula here when it says absolute value is 0, telling us to use a third degree polynomial. And the reason they're telling us to use a third degree polynomial is because we wrote the fifth degree polynomial in the first one. And we'll need to use this term, x to the power of 5 over 5 times 6 factorial. That would be an important thing to use for the Taylor polynomial. For G, about x equals to 0, same thing, same center. To estimate the value of g sub 1, so I need to know that, so because it's being evaluated at x equals 1, and estimate, and explain why this estimate differs from the actual value of g sub 1 by less than 1 over 6 factorial. Okay, so I'll get there. So what I did originally is I wrote g sub x is equal to my thing again, just to make sure I don't mess anything up, and then I evaluated it at x equals 1. But the thing is, though, I'm not using this fifth degree because it's telling us to evaluate it using the third degree. So we have our terms here, okay? So we have 1 minus 1 over 2 factorial plus 1 over 3 times 4 factorial. Okay, I'll state why this is here. But if you like smash all these together, you'll get 37 over 72 factorial. So g sub 1, the real g sub 1 minus this as we're using the series should be less than the next term, or like this one is bigger than the next, like it's, this is less than the next term, which is 1 over 5 times 6 factorial. We'll state that we're showing this why it's estimated by the value of g sub 1 by less than 1 over 6, because this is, it's smaller than 1 over 6 factorial. If this is bigger, it would not work at all. So we would state the alternating series test for error as less than the first term. Left out error is less than So the error originally is less than 1 over 5 times 6 factorial, and 1 over 5 times 6 factorial is less than 1 over 6, as required by the alternating series test. So this is just saying R sub n, S of n minus S of what, like whatever, like S of n plus 1. So like well, this is S of n plus 1. So it's very, in a way, similar to Lagrange error, except for using the big formula. Okay, those are mainly my big tips and tricks. Mainly, I would say just for this one, there aren't many shortcuts except for just remembering these cosine of x terms, which are really important, and just identifying what you need to know and how you'll do everything. Okay, thank you.